Hi there, Physics 1. This is the second video that I've been making, and this is starting with Chapter 1. Hopefully you'll get access to Pearson in the next day or two so that we can get started. Because of the pace of the summer class, you should get Pearson as quickly as possible. Don't want anyone to get behind. So with that, I want to talk a little bit about the nitty-gritty of how we're going to do the class every day. So I'm going to be streaming from my computer. We'll be doing this lecture. I'll upload it to YouTube the night before, so you can watch it whenever you want to. And it will cover the class notes. There's going to be some material not in the book, but this is college, and so that's just part of how life is, basically. And I'm going to be adding a lot of biological examples because I will be augmenting this to have it more of a biological perspective, which I think most of you will appreciate. So behind me here in my Zoom background, this is the Orion Nebula. I do love astronomy, but that's the bigger picture. So, but let's start talking about Chapter 1. I know that many of you don't have the book yet, so let's just talk about why physics. Why are you taking this class? Why is physics important for biology? I know that maybe some people were afraid of physics. You shouldn't be. Physics is great. It's just like any other science. But I think possibly it's because there's a little bit of math in physics. So let's talk about why physics. All right. So this is Physics 1, and I am Dr. Wisby, and this is for summer 2020. So starting today, Monday, 5/18, and a lot of this lecture comes from my colleague Jean Potvin, who his research is about the physics of whales. So he does some really interesting things, and I was really excited to be able to teach this because I've always wanted to learn about all the biophysics that he's doing. And this class was the perfect opportunity for me because every time I teach a new class, I also learn something new. Okay, so here you are, a life science major sitting in a physics class, and you are stuck in class, and you just can't wait to see you. So, yeah, maybe this was not your first choice, but you might feel like running away. But you don't need to do that because I'm here to help you. So you don't need to run away. If you haven't seen Monty Python before, it's a great movie, The Holy Grail. So maybe you feel like running away, but with this class, I want to help you appreciate why physics is so important, especially today, all the medical advances. Why is it important for biology? Maybe you've already thought of some examples. One of the biggest things are x-rays. Where would modern medicine be without imaging material? So why should you stay in physics? Well, it's probably required for your program. Your elders think that it is important for you to have, and physics is important to biology and medical science. So we look at the 1800s, it was a much more sort of primitive approach to medicine. Things were pretty barbaric and people were afraid to go to the hospital, but we've advanced a lot since then. And I think physics has had a big role in the advanced medicine. Your elders want you to know some physics. They believe it's important. Um, this Transforming Undergraduate Education for Future Research, the report published by the National Research Council, encourages, among other recommendations, deeper physics preparation for basic research in biology. Physics is becoming more and more important for biology all the time. And as you really start to get down to the fundamentals of biology, you see that there's so much physics involved in it. The human body is just a walking physics experiment. And it's really important for, if you really want to understand biology at the atomic level, the chemical level, it's so important. Scientific foundations for future physicians. These are both panels that have decided that physics is important in biology. So they called for a greater understanding of principles of physics and the applications to medicine. So physics is huge in medicine. There's so much technology in medicine. Physics is critically important. Physics is important to biology and medical science. Number one, the physics-based technology in medicine. So in the 18th century, medical technology looked like this. This was a kit that they used to saw off limbs. And we've come quite a long way. So here we've got a picture of a prosthetic limb. Now with the aid of physics, people are able to run again and walk without, even though they've lost a limb. We have MRIs, we can actually image inside of the brain and the human body. And of course, where would medicine be without a microscope? So that is just pure optics. And then of course, seeing inside of the womb, when my son was, before he was born, we could actually see inside of his womb. We could see his heart, we could see him growing, and it was amazing. So and physics has made huge contributions to medicine. Physics is important to biology and medical science. Number two, new physics-based technology in biology. We can track animals using radio waves and electronics. Here we've got they're tracking sea turtles. They also do this with whales and seabirds. So this is critically important for conservation and understanding the behavior of animals. Physics is important to biology and medical science. Physics provides important constraints on how cells and organisms grow, live, and evolve. So the reason that animals are the way that they are today is because of physics. Some example questions are, why can't we find ants that are a foot or 10 feet tall? Why isn't that possible? How come bugs can walk on water? I can't walk on water. I used to try when I was a kid. Somehow insects are able to do that. Why can't humans? Why can't bigger animals? Why is it hard for juveniles to walk or swim along with their parents? How come animals just can't start walking? Why do some of them do it at different rates? How fast is O2 transferred from the air in the lungs to the bloodstream? And why is fur or fat and clothing so efficient in keeping animals and humans warm? Why do whales have blubber? Somehow, even though they're mammals and they have the same body temperature we do, they're able to survive in Antarctica, where the water is sometimes below freezing. So this is all possible because of. So questions to be emphasized in this class, Physics 1. What are the fundamental principles of physics? What is the basis of what we're doing in physics? And how do those principles describe the movements, forces, and energy used by living organisms. So how can we apply physics to living organisms? What are the constraints of physics that affect how cells and organisms grow, live, and evolve? How are physics principles used in the design of biological, medical science diagnostic instruments? There's a lot of technology out there and a lot of engineering and physics that are involved in these machines. So you may have taken physics in high school. We're going to take those same principles and apply them to living organisms. So number two, how do these principles describe the movements, forces, and energies used by living organisms? So when a whale is swimming through the ocean, it's using energy. It has to eat a huge amount of food every day to store up enough energy to swim halfway across the ocean. And as it's moving, it's using energy, and the force of drag is slowing it down. So it's got to have enough energy to get where it's going and overcome the force of drag. How can physics affect cells? So what is the length of the hypotenuse of this triangle? If one side is equal to 6 centimeters and the other side is equal to 8 centimeters. So let me say a little bit about technology at this point. I'm going to be switching periodically to my document cam. This is going to allow me to write problems and do examples online. So this is a little bit better than writing on a board. So I hope that this is helpful. Okay, so let's draw a picture of the problem. And personally, I always find it helpful and instructive to draw a picture whenever I have a physics problem. It helps me to understand it on a much deeper level, and I think it's something that really helps you to connect with the problem. So let's draw our triangle like this. The base is longer, and our base here was 8 centimeters long. And here's the hypotenuse of our triangle. Then over here, this side was 6 centimeters long. And of course, if you want to find the hypotenuse of a triangle, we can say that this side is equal to A, this side is equal to B, and this side is equal to C. And of course, we're going to use the Pythagorean theorem. If you don't know where the Pythagorean theorem came from, well, the Pythagorean theorem came from a mathematician named Pythagoras, and he lived on an island in ancient Greece, and he sort of had a cult, and everyone on the island was a follower of the cult, and the reason that we know about this is because one of the cultists actually escaped from the island. They were forbidden about talking about this with anyone, but supposedly they knew much more than just the Pythagorean theorem. Most of what they knew was lost, or maybe they never knew anything at all, but this one cultist did escape, and he gave us the Pythagorean theorem. So that's how we know. And the Pythagorean theorem, of course, says that a squared plus b squared equals c squared. Okay? So if we know a and b, let me write that again. A squared plus b squared equals c squared. And if we want to know what c is, then we can take the square root of both sides. We'll write this as a squared plus b squared equals the square root of c squared. So, of course, if we have a square of a number here under the radical, which means take the square root of that, well, what that really says is c times c is equal to a squared plus b squared. Well, we've got two of those there, so this just equals c, and then we have a squared plus b squared equals c squared. Now you'll notice that I kept this in symbolic form until I had it in this form. And now I'm going to put my numbers in, and then we're going to see what C is equal to. Okay, so I'll switch C over here, and I'll write my two numbers in here under the radical sign. We'll have 6 squared plus 8 squared, and we'll take the square root of that. Well, 6 times 6 equals 36. So under my radical here, I will have 36 plus 8 squared, which is 64. So 8 squared is just 64. And that will all be equal to C. Well, if I add these up, 36 plus 64 is equal to 100. And I know that 10 times 10 equals 100. And so the square root of 100 is 10, and that gives us our answer, C equals 10. But we're forgetting one important thing, the units. This number is in centimeters. Do not forget the units. Now, if you want to calculate this, fortunately, we live in a world where we have, of course, the iPhone here. So I have my calculator app right there. And if you are ever in doubt, you can turn this sideways. And of course, this brings up your scientific calculator. Wow, isn't that great? A scientific calculator right there on your phone. So of course I could say, well, I want to find the square root of 100. So I type in 100 there, and I would say push that button right there. That is, I don't know if you can see it, find the square root of x, so it's 2 over x, and that's the square root, and so of course it would give me 10. Okay, so you can use the calculator on your phone. I also will be using Mathematica throughout the semester, but I think all of you should have something like this built on your phone. Of course, if I hold my phone like this, it goes back to just your basic calculator. But you can unlock, the scientific calculator, and I have a little shortcut here on my thing to get right to the calculator, and I'll get out my scientific calculator. There we go. So you could use this for the class, or probably a more standard scientific calculator is better, because I do not have a record of this. Another thing that you could do, well, that's great about a scientific calculator, is that it keeps a record of it. What's great about a scientific calculator is that you can keep a record of what you did. So depending on your calculator, you might be able to say, let's a squared plus b squared equals c squared. And what's great about a scientific calculator is you can hang on to this for a while. So you could actually put a radical symbol here and say 6 squared plus 8 squared. And then if we put that in, I'll put a little decimal sign there, equals 10. So scientific calculators should be able to handle this no problem. But a problem like this, hopefully you will be able to at least do it partly on your own. Now, this program is called Mathematica, but basically it's a scientific calculator. So if you have a modern scientific calculator, and as you type in your equations, it will keep a record of them. So that's something that's useful. So hopefully you have a scientific calculator for this class, something that you can keep track of things in. Well, that brings us to the end of our second video for today. We talked a little bit about what the class is going to be over, and we will incorporate biology whenever possible. I intend to teach physics from the perspective of biological physics. So this is not going to be just a standard physics class. We are going to use a lot of examples from biology and specifically the human body. So it's not quite a standard physics class, and it's going to require us to get a lot of information from outside of the textbook. Uh, but I will supply that with you for you, and you'll also be looking some of it up online. Thank you for watching, and I look forward to meeting you all later in Zoom. Thanks for watching.